Hello, welcome to Algebra 1 with Miss Andrea. Today we're going to get into the next unit, um, which is Unit 3b. So we're taking quadratic equations that we began to learn about in the last unit in 3a, and we're learning some more about it. Specifically, we're going to look at how to graph them in this unit. In the past, I tried to keep up with the modules and the units. I am now going to just simply call it by the unit number because it's messed up for the rest of the class through the online book. So we're going to continue to just stick with what is online to make everything cohesive. All right, so Algebra 1, Unit 3b, which is graphing quadratic equations, and this is page 1. So let's get to it. There's 5 questions that we're going to make sure are addressed in this unit. How do I graph a quadratic function? We're going to look at several ways to graph a function. Where's the maximum or minimum of that function located? And what does it mean in a word, like if you have a real life word problem in the context of a problem, how does that help me get information? What is the rate of change for quadratic function? And how is that different from one for a linear function? And then how can the graph of, this is the basic graph for a quadratic equation is x squared, or f of x, or y equals or is x squared. How does that move up, down, left, right, stretch, or compress? And so we're going to look at every single one of those questions in this unit. But some key terms we wanted to go over is axis of symmetry. Now, you are already familiar with the fact that a quadratic equation, as we discussed, is in the shape, when you graph it, of a parabola. So an axis of symmetry is where you can cut a line down the center, and this half is exactly symmetrical to this half. So if this is 1, 2, 3 away from there, this one's 1, 2, 3 away from the axis of symmetry. You can, just like in elementary school when you learned about symmetry, you could take it and fold it in half, and the parabola would be exactly on top of each other. Okay, so axis of symmetry. Horizontal shift. Going back, if we started with a parabola that looked like this, a horizontal shift would mean it's traveled to the right or the left. And so in this case, this one's gone to the right. And they're supposed to be exactly the same. My green one isn't quite as parabolic as the purple one, but it's supposed to just shift to the right or to the left. Leading coefficient. Okay, so remember we have standard form, which is ax squared plus bx plus c equals 0. This is the standard form of a quadratic equation that we got into in the last unit. And so the leading coefficient is whatever this a is right here. Now, that doesn't matter if it's first or not. So if it's not in standard form and this isn't the first term, this is still the leading coefficient because you need to put it in standard form. Okay, so this is the leading coefficient and gives us information such as if it's a negative number, the parabola will open down. If it's a positive number, it will open up. Okay, so the leading coefficient is very important information. Maximum value. All right, so again, we had 2 parabolas, one opens down, one opens up. So the maximum value is the number, the highest value that so what's the maximum y value? This is the highest point that this parabola can go to. If this point were, say, 3, 7, okay, that means it's 1, 2, 3 over and 7 up, right? So that means its max is y equals 7, okay? So there's also a minimum value, right? So if the maximum value was a parabola that opened down, a minimum value would mean that it's on a parabola that's going to open up. A minimum value is the minimum, the smallest value that the y can have on this parabola. Parabola. We've been saying that word a lot already, so hopefully you know what it is. It's the shape that a quadratic equation makes when it's graphed. It's an arc, like when you kick a ball. If you were to throw something in the air and it would go up and then eventually come back down. That's a parabola. Same thing with if you, I don't know, maybe had a yo-yo and you threw it down and then rolled it back up. It kind of would do that same kind of. If you held a string at two ends, the shape that the string would create in between would be a parabola. All right, quadratic function. A quadratic function is any function in which the variable is raised to the power of 2. So 7x squared plus 3x minus 5. This is f of x is. So instead of saying y, you use your f of x. Okay, so that's the function part of this. The quadratic variable is raised to the power of 2 or squared. And that's the quadratic part. And remember, just going back to that quadratic function, remember a function has to pass the vertical line test. So your parabolas are either going to be straight up or they're going to be, oops, that's not straight down, or they're going to be straight down, okay? These are the functions, quadratic functions. If you had a parabola that went to the right or to the left, this one would be the right, that would be the left, they would not be functions, okay? Now, you're like, well, how does that happen? Well, that's when y is squared instead of x. Y squared equals something like 3x, who knows? But that's when y is squared. So we're specifically talking about when the input variable or the independent variable or the domain is what's being squared. Okay, so quadratic function is when like the x is being squared, not the y. Root, we already kind of talked about what roots are because they are the solutions to the problem. The roots are where the parabola or the graph of the function crosses the x-axis. Roots are sometimes also called zeros, okay, or solutions. So the root of the problem. The root is the answer. All right, standard form of a quadratic equation. We've gone over that. Hopefully you have it memorized. If not, at least you have it written down. This is the standard form of a quadratic function, and you would say f of x, since it's a function. So ax squared plus bx plus c, where a, b, and c are all real numbers. And we use this to find the solutions and do other important things with the quadratic functions. Vertex. Remember when we talked about a minimum and maximum point? And I really don't do justice to this parabola. It's supposed to really come to a definitive point at the top, like that, because there's only one point at the top. It's not supposed to look as flat as when I draw it. This is the vertex. And a vertex is written, you know, with the x value and the y value. The vertex, the x value of the vertex and the y value of the vertex is right here. Now, if you notice, the vertex is on the axis of symmetry, okay? And if you notice, the vertex is also the maximum or the minimum. The vertex is where the parabola changes directions. So when we're moving, if we are kicking a ball, instead of moving upwards, the vertex is right where it starts to move downwards, okay? Same with it going this way. If the vertex is right here and we're following down this curve, the vertex is right where it starts to move up the curve. Vertex form of a quadratic function. Okay, we are going to get into that in a future lesson, but this is a form of the quadratic function in which I think it's something like, I can't remember it exactly, h minus k squared plus b equals 0. I don't know. Something to that effect. Don't write that down. We'll get to it soon. But what it is you're going to have an h and a k in there, and they're both going to tell us exactly what the vertex is. So we can just look at the problem and see what the vertex is. Whereas like the standard form, ax squared plus bx plus c, you can't look at this and say, oh, I know what the vertex is. We're going to see in the next lesson how to find the vertex for that. But you can't just look at it and be like, oh, I know what the vertex is. When you're in the vertex form of a quadratic function, you can just look at it and say, oh, I know what the vertex is, and write down the answer. So that's what the vertex form of a quadratic function is. Y-intercept. A y-intercept is where the parabola crosses the y-axis, right? Not the x-axis, but the y-axis. And remember how to find y-intercept is you plug 0 in for x and solve. And that gives you your y value for 0. That gives you your y value that you're going to put in right there. Okay. And then our last term today is x-intercept. And we know already, we've talked about it several times, x-intercept is where the graph crosses the x-axis. Now that can happen at 2 places. It can also happen at 1 place, if I did a good job there. Or sometimes you don't have a parabola that crosses the x-axis. And so there's no solution here. No solution. This is 1 solution, and this is 2 solutions. Okay, so remember where it crosses the x-intercept is the solution, right? And another way to call these are roots, solutions, or zeros. And in these cases, you're going to say x equals, okay? But when you have an x-intercept, what you're going to say is you're going to have it in an ordered pair, and your y will be 0. And your x-intercept is what you need to find. And that we've gone over our last unit. We went over all different kinds of ways to figure out what your your root, your solution, or your 0 is. And that's what you're going to put into that blank spot in the ordered pair of the x-intercept. All right. Well, those are all the key terms. I hope you understand them all. I look forward to working and learning together with you about how to graph quadratic equations. Coming up in the next lesson, we'll explore it some more. So we shall see you in the next lesson. Bye.